Hello friends, I welcome you all to this class. This is real analysis class, and today we'll be solving the example 4 under this topic, the order relation. So let's see what this question says. They say we should prove that for all A, B, C, D elements of real numbers with the condition such that A, B, C, D, each of them are greater than or equal to 0. We should prove that square root of AB multiplied by square root of CD will be less than or equal to 1/4 of A squared plus B squared plus C squared plus D squared. This is what we are required to prove. This condition is just, they are giving you the condition that each of the four real numbers must be greater than or equal to 0. So we are going to start the proof. Solution. So we are going to write this now. A squared minus square root of A squared minus square root of B squared, all squared must be greater than or equal to 0. Now A squared will give you what? A positive real number. B squared will give you a positive real number. We know that square root of any positive real number will be a real number, but square root of negative real numbers will be a complex number. So since A squared will be a positive real number and B squared will be a positive real number, then square root of it will be will also be what? A real number. So because of that, square root of A squared will be a real number, square root of B squared will be a real number. If you subtract two real numbers, to give you another real number, right? Then the square of it, because we are having all squared, the square of it, square of any real number must be what? Positive. That's why I wrote that this is greater than or equal to 0. So if you expand this, this will be square root of A squared minus square root of B squared multiplied by square root of A squared minus square root of B squared greater than or equal to 0. So it is true that square root of A squared is A and square root of B squared is what? B. But I wrote this due to the nature of the proof we want to show here. That's why I wrote it like this. So this implies, let's just multiply square root of A squared multiplied by square root of A squared will give you A squared. Positive square root of A squared multiplied by negative square root of B squared will give you negative square root of A squared B squared. Then negative square root of B squared multiplied by positive square root of A squared will give you negative square root of A squared B squared. So negative square root of B squared multiplied by negative square root of B squared will give positive B squared greater than or equal to 0. So this implies A squared negative square root of A squared B squared negative square root of A squared B squared will give you what? Negative 2 square root of A squared B squared. Then plus B squared greater than or equal to 0. So this implies, can we move this negative 2 square root of A squared B squared to the right? So let's do that. If we move it to the right, it change to positive. So the only thing we have at the left will be A squared plus B squared. So we have A squared plus B squared greater than or equal to 2 square root of A squared B squared. So quickly, what I need here is, I need the square root of A squared B squared only at the right. So let me divide both sides by what? 2, so that I can get that. Divide both sides by 2. So this implies, so A squared plus B squared divided by 2 have A squared plus B squared divided by 2 greater than or equal to 2 square root of A squared B squared divided by 2 have square root of A squared B squared. So this implies A squared plus B squared divided by 2 greater than or equal to, square root of A squared B squared. Square root of A squared B squared will give you AB, right? So we can call this one equation 1. You can see the reason why I wrote this at the first instance, square root of A squared minus square root of B squared, because because of what we have here, we're having a squared, b squared, c squared, d squared. So we are going to do the same also for c and d. Similarly, at least we have gotten a squared, b squared here, right? So I've gotten it here. So similarly, the same thing that happens for a and b will also happen for what? C and d. That's why I wrote similarly. Similarly, c squared plus d squared divided by 2 will be greater than or equal to c times what? D, as it's happened for a and b. So this will be, I can call it 2. So let x squared be equal to a squared plus b squared divided by 2, and y squared be equal to c squared plus d squared divided by 2. So you know, a squared is a positive real number, b squared is a positive real number. If you add them, you give another positive real number. If you divide it by 2, it will give you what? Also a positive real number. So it fits in at this condition. So I can say let x squared be this a squared plus b squared divided by 2, and y squared be c squared plus d squared divided by 2. So x squared must, this will be positive and this must be what? Positive. So because of that, then x squared plus y squared divided by 2 must be greater than or equal to xy. Since a squared plus b squared divided by 2 is greater than or equal to ab, and c squared plus d squared divided by 2 is greater than or equal to cd, then x squared plus y squared divided by 2 must be greater than or equal to what? Xy. So this implies, what is x squared? X squared is what? X squared is a squared plus b squared divided by 2, and we're having plus here, right? Y squared is what? C squared plus d squared divided by 2. Then we're having all divided by what? 2, greater than or equal to, what is from here? X squared is a squared plus b squared divided by 2. So x will be square root of a squared plus b squared divided by 2. So x will be, this x will be square root of a squared plus b squared divided by 2, and y will also be square root of c squared plus d squared divided by what? 2, right? So this will be, so because if it comes to equation of y, since y squared is c squared plus d squared divided by 2, then y will be square root of c squared plus d squared divided by 2, right? So this is what we are going to have. So quickly, let's just create space here. Let's create space here. Okay. This implies, then what is the LCM of this numerator? LCM is 2, so I'm going to have 2 into a squared plus b squared plus c squared plus d squared. Then we're having divided by 2 again, greater than or equal to, we're having square root of a squared plus b squared divided by 2, square root of, so this, we are having square root of a squared plus b squared divided by 2, square root of c squared plus d squared divided by 2. You know that square root of x, square root of y is same thing as square root of what? Xy. So I'm going to write this as, this will be square root of a squared plus b squared divided by 2 multiplied by c squared plus d squared divided by 2. So because square root of x multiplied by square root of y is the same thing as square root of xy. So this is what we have there. So this implies a squared plus b squared plus c squared plus d squared divided by 2 will be, you are dividing it by 2, dividing it by another 2. It means you are dividing it by what? 4. So I'm going to have a squared plus b squared plus c squared plus d squared divided by what? 4 is greater than or equal to so what do we have here? Square root of a squared plus b squared divided by 2, c squared plus d squared divided by 2. So greater than or equal to this quantity a squared plus b squared divided by 2, this quantity inside a square root is greater than or equal to ab. Then and c squared plus d squared divided by 2, this quantity inside a square root is greater than or equal to what, cd. So I can put that this thing I have here will be greater than or equal to square root of ab multiplied by what, cd. So this is what, that's square root of ab cd. So this quantity, you know, this, let's just say, okay, let's just write here square root of, you know, square root of, I told you that square root of x multiplied by square root of y is same thing as square root of xy, right? So square root of ab multiplied by cd, that's square root of abcd, will be the same thing as what, square root of ab square root of what, cd. So this quantity is the same thing as this. That's why I put equal to here, because this is this. So this simply implies a squared plus b squared plus c squared plus d squared divided by 4 is same as 1/4 of a squared plus b squared plus c squared plus d squared. So this will be 1/4 of this, then greater than or equal to, so we have that this quantity is bigger than what, this quantity here. That's the first quantity we have here is bigger than the second quantity, and the second quantity is bigger than what, the third quantity. So it means that this first quantity is bigger than what, the third quantity. So this will be bigger than square root of ab square root of what, cd. So if we have that 1/4 of, if we have that 1/4 of a squared plus b squared plus c squared plus d squared is greater than or equal to square root of ab square root of cd, it implies that square root of ab square root of cd will be less than, so this square root of this simply means that the square root of ab square root of cd will be less than or equal to 1/4 of a squared plus b squared plus c squared plus what, d squared. So this is what we have. You know, if x is bigger than y, that is, if x is greater than or equal to y, it means that y will be less than or equal to what, x. If this quantity is bigger than this quantity, then this quantity will be less than what, this quantity. So if this quantity, we are having that this quantity is greater than or equal to square root of ab square root of cd, then square root of ab square root of cd will be less than or equal to this quantity.